So for the first one, what method did you use to try to solve it? Or what method would you use for those of you who haven't got it done yet? I'd solve it for y. Okay, so we're going to subtract 3x. So y equals 1 minus 3x. Is that what you're thinking? So plug that in up there for 2y. So now this up here becomes 7x minus 2. Instead of y, I'm going to put in 1 minus 3x equals 24. And now we solve. So we got the 7x doesn't change. So we have negative 2 times 1 is negative 2. Negative 2 times negative 3x is positive 6x equals 24. Then what? So 7x and 6x make 13x. Minus 2 is 24. And then add 2. 13x equals 26. And yeah, we'll divide by the 13. So x equals 2. Now, of course, we're not done. We still need to find y. But y equals 1 minus 3x. So y equals 1 minus 3 times 2. Y equals 1 minus 6. Y equals negative 5. Any of you get that done and have 2 negative 5 as your answer? Good. For the next one, what method would you prefer to use? Let me scroll up to it so you can see it. You could combine them, but you'd have to multiply the top equation by 3 or multiply both of them to get rid of the y. Let's do that. I'm going to multiply this top equation by 3. So now 3 times x is 3x. 3 times negative 3y is negative 9y. 3 times 9 is 27. So now I'm working with those two equations. I add negative 3x and 3x, cancel out. 2y and negative 9y make a negative 7y. And 1 and 27 make 28. We divide by negative 7. Y equals negative 4. And now we have to go back and find x. I can go back to either of the original equations. I'm going to use that top one. So I'm going to use x minus 3y. Well, for y, I'm going to put in negative 4 equals 9. I've got negative 3 times negative 4 is a positive 12 equals 9. Subtract 12. X is negative 3. So that is negative 3, negative 4. Anybody have that one done? Did you get that? Cool. Yep. Yeah, it kind of is because the equal sign isn't getting divided. You're doing 2 separate divisions. So technically you should do them separate, but as long as you know what it means, that's not part of the answer, it's part of the process. So it's not wrong if you do it.
Even if you get told to show your work. As long as your grade matter knows what's happening, you do.
If you get told to show your work, it varies a lot from one instructor to the next as to what they consider work. So, okay, so today we are going to take the next step. Nice try. At least you hope it's in 2 weeks. You could be on the 2-year plan. Who knows? So here we have a system of 3 equations, 3 variables. Now we've seen if we only have 1 variable, we only need 1 equation. We can solve a single equation for a single variable. If we had that second variable, we had to have 2 equations. We had to have a system of 2 equations. If we have 3 variables, we have to have 3 equations. If you haven't noticed the pattern yet, for every variable you have to add an extra equation. An equation, if you want to talk about it in engineering terms, a variable is considered a degree of freedom, and an equation is considered a constraint. So for every degree of freedom, you have to have a constraint. It has to be a unique constraint. You can't. There's problems where you can write 2 different equations, but they're actually the same equation. And we'll run into some of those before we're done this semester. But for right now, we have to solve this system of equations. There are 2 methods that we have available to us right now. One of those methods is the substitution. Now, graphing, we're going to just completely leave out. Graphing here would be ugly. 3-dimensional graph looks something like this. There's X and Y. You're kind of looking at it from up above and at an angle. Those are at right angles to each other. And then Z, of course, goes like that. So if I put a point here, who the heck knows where that is, right? Is it up, down, or whatever? Normally what we would have to do is something like this. Actually, I drew it wrong, but it's okay. Yeah. So if this is your point, tracing it down and over is giving us y is 2. Tracing it down and over here is giving us x is 5. And over z is 3. So that's how you'd plot the point 5, 2, 3. But you have to have that kind of shadow box there so you can find it. Because it is a box with one corner at the origin and the point is at the opposite corner of the box, the diagonal corner of the box. Well, you can't plot too many points before those boxes all overlap. And plotting a line is a real nightmare. So graphing to solve a system of equations for 3 variables, really not practical. Unless you're using electronics, a software package of some sort. So we're not going to talk about graphing as an option for solving a 3-variable system. We're going to start out with substitution. Now, just for ease here, I'm going to label these equations A, B, and C. If I'm going to solve by substitution, I want to get one variable by itself. So usually I look for that variable that has a coefficient of 1 or something that I can divide by and it won't leave me too harsh of decimals. Like 2, you can always divide and you get 0.5. You'd want to avoid dividing by 3s or 6s or 7s. Well, looking at this, is there a variable here that would be easy to solve for? In equation A, y wouldn't be bad, but it's negative. In equation C, solving for z is probably the easiest way to go. So in equation C, I am going to subtract 3x, get 2y plus z equals 1 minus 3x. Then I'm going to subtract 2y. Get z equals 1 minus 3x minus 2y. So this is going to be used to replace z. Well, where is it going to be used to replace z? Well, what equation did I just solve? C. So that's going to be used in equations A and B. So let's start out with equation A. 5x minus y plus 2z. Well, z becomes 1 minus 3x minus 2y equals 15. Doing a little bit of work here, we're going to multiply through by the 2. So 5x minus y doesn't change. 2 times 1 is 2. 2 times a negative 3x is negative 6x. And 2 times a negative 2y is negative 4y. So now we can combine. 5x and negative 6x makes negative 1x and negative x. Negative y and negative 4y make negative 5y. We got plus 2 equals 15. So I'm going to finish that off by subtracting 2. So negative x minus 5y equals 13. That is my modified A. We call it double A for now. What equation haven't I touched yet? B. So we're going to, equation B, 2x minus 2y plus 3z, only z is 1 minus 3x minus 2y. Now I'm going to pause. Anybody have any questions on how I got to this? Anybody have any questions down here as to where this line here came from? It's just this equation here, only I replaced z with that. So what do we do next? Well, we got to multiply through by the 3. So the 2x minus 2y does not change. 3 times 1 is 3. 3 times negative 3x, negative 9x. 3 times negative 2y, negative 6y equals 13. So I'm going to pause there. Any questions where that came from? Need time to write it down? We probably won't get to 8 variable equations. That would pack a lunch and stay for the day type of thing, yeah. Unless you've got a graphing calculator, but I'm not going to, I would not recommend you spend $120 just for a week's worth of class. If you're going to spend that kind of money, just give it to me. Two x minus 9x is a negative 7x. Negative 2y and negative 6y is a negative 8y. Plus 3 equals 13. And we have to subtract 3. So negative 7x minus 8y equals 10. That is, we call that BB. That's our modified equation B. Now you'll notice we haven't solved anything yet. All we have managed to do is reduce this equations A and B down to 2 variables. Yes. Now we have a system of 2 equations in 2 variables, A and BB. If you recall, when we were solving a system of 2 variables up here, what we did was reduced it to an equation with only 1 variable, and we could solve that equation. Now here we substituted in for the y with an expression in terms of x. Here we did elimination to get rid of the x, so now it's all an equation with just y. So the point with 2 variables and 2 equations is to reduce it to a single equation with a single variable. When we have 3 variables and of course 3 equations here, the first step is to reduce it to 2 equations with 2 variables, like we did here. So we have negative x minus 5y equals 13. Negative 7x minus 8y equals 10. And now we're going to solve that system. I would take this top equation here and multiply it by negative 7. Why am I doing that? Yeah, negative 7 times negative x is a positive 7x. Negative 7 times negative 5y is a positive 35y. Equals, and negative 7 times 13 is a negative 91. So now I can do elimination. Negative 7x and positive 7x are gone. Negative 8y and positive 35y make 27y. 10 and negative 91 is negative 81. And then we divide by 27. Y equals negative 3. We found y. Guess what? We got two variables to go. How do we find x? Well, we go back to one of these equations up here. In fact, we could use this one if we wanted to. But I'm going to do this. Negative x. Now I'm going to think of this negative 1x minus 5y. Well, for y, I'm going to put in negative 3 equals 13. Everybody see where that negative 1 came from in front of the x? Just a negative x is the same as negative 1x. So now, negative 1x, negative 5 times negative 3 is a positive 15 equals 13. Subtract 15, negative 1x equals negative 2, and divide by negative 1. X equals 2. So far I have y equals negative 3 and x equals 2. I need to now find z. Well, we have this nice neat little expression right here for z. Z equals 1 minus 3x minus 2y. So z equals 1 minus 3 times 2 minus 2 times negative 3. Z equals 1 minus 6. Negative 2 times negative 3 is a plus 6. Equals 1. Z equals 1. So we have x is 2, y is negative 3, z is 1. 2, negative 3, 1. What do you think? Loads of fun? You really have to stay organized, yes. Have to be neat. I mean, even my handwriting's sloppy enough that it's easy to make a mistake. A lot of things that you got to keep labeled so you know what they are, so you know, because you're going to have to go back to them. This is where using the computer is a little difficult. It was nice back, because I mean, that's why I have 3 boards in here, is I could do something up on the front board and leave the equations up there and then go to one of the side boards and keep working and refer back. Here you got to scroll up, scroll up, scroll down, all that good stuff.
You can use the boards if you want.
I can't record them that way though. Well, I could if I could use a POV camera, but that's no fun. Two more projectors, just shoot them off. Get the triple screen computer. That'd be one way to do it. Yeah.
Or a projector that projects on a curve and get one board that goes from there.
That'd be interesting. Yeah, but then Eugene would be like the deer in the headlights over there. The projector would be hitting him in the face. Okay, well, let's try another equation. Why not, right? Usually takes me a second to put these together, so be patient with me. I remember the day when my mind was pretty sharp and I could just buzz through these. These getting old thing sucks. Yeah.
that they're actually solvable.
They're solvable.
Okay, this one here, yeah, they're solvable. They're just not pretty.
I mean, if you don't pay attention at all, though, you can end up with some that aren't solvable, correct?
Yeah, you can end up with some that are parallel planes and stuff like that. Yeah, you have no solution or infinitely many solutions. Okay, now for this one, since it only took us 25 minutes to do the first one, we're going to solve this one by the elimination method or the addition method, whatever you call it. Once again, we're going to label our equations for ease of reference, A, B, and C. Now, just like with two variable systems, if we're going to use elimination, we need a variable that's going to cancel out. Because we need it to cancel out. No, just kidding. I know what you're saying. With a variable y here, would be very easy to cancel out. Sorry, I couldn't resist. If we do equations b plus c here, so you got positive 1y and negative 1y, that's going to cancel out. You guys need me to rewrite the equations? Can you handle me just adding them together here? So you got 2 plus negative 5 is a negative 3x. Positive y plus negative y disappears. Negative 2z plus z is a negative 1z, or just negative z. Negative 3 plus 21 is 18. So there is one equation right there. Now, I am going to keep equation B. I'm going to use equation B again, but I have to use equation A. And I have to eliminate y. I eliminated y the first time. I have to eliminate y again. I have to be the same variable that I get rid of. So I have to do 2 times equation B. So 2b, that's going to be 4x plus 2y minus 4z equals negative 6. Everybody see where this came from? I took equation B and I multiplied everything by 2. So now, if I do equation A plus 2 equation B, I've got 3 plus 4 makes 7x. Negative 2 plus positive 2y cancels out. 3z plus negative 4z makes negative 1z. Negative 26 plus negative 6 is a negative 32. Now I have 2 equations, 2 variables, just like I did before with the substitution. And now I have to get rid of one of those variables. So what I am going to do is I'm going to multiply that top equation by negative 1. Why am I going to do that? It's going to give me a positive 1z. You got it. So that's going to become positive 3x, positive 1z, negative 18. So now I'm going to add 7x and 3x make 10x. Negative 1z and positive 1z cancels out. Negative 32 and negative 18 is negative 50. We divide by 10, x equals negative 5. So now that we know that x is negative 5, what's the next variable we have to find? Actually, we have to find z next.
You can struggle if you set up the other one.
Well, you could go through a whole lot of work to get y. But we're set up to find z next because our system of 2 variables is x and z. So we go back to find z here. So I'm going to do the second one here. 7x is going to be 7 times negative 5 minus 1z equals negative 32. So this is negative 35 minus 1z. It's negative 32. Add 35. Negative 1z equals a positive 3 divided by negative 1. Z equals a negative 3. Now I can find y. I'm going to go back to my original equation B. 2x is going to be 2 times negative 5 plus y minus 2z is going to be minus 2 times negative 3 equals, what's that, negative 3, wasn't it? Yeah, negative 3. So now we'll work this out. 2 times negative 5 is a negative 10 plus y. Negative 2 times negative 3 is a positive 6. Negative 10 and 6 makes negative 4 plus y equals negative 3. And we add 4. Y equals y. So our solution, x is negative 5, y is 1, and z is negative 3. What do you think?
Could be worse.
Yeah.
Just go with it. When you're finding C,
Yep.
does it matter what equation you plug it in?
Nope, I could use, actually I could use any of those three.
Any of those three?
Yep, even the one that was modified here I could use. Probably would have been easier to use that one because the variables were both positive there. Kind of tedious. Anybody totally blown away right now? Anybody?
You're one way along while you're
Well, that's just, this one only took me about 8 minutes to do. Obviously, the elimination's a little faster, substitution's a little slower. But there are systems where substitution is the easier way of doing it. For example, I might run into a system like this. And yes, I'm getting old, so I have to have my little cheat note up here. If we get a system like that, substitution is by far the easiest way to solve it. Because this bottom equation, I can divide by 5, I got x equals 2. I've already got x. Well, this next equation is just x and z, so I put in 2 for x. 2 times 2 is 6, minus 2z equals 4. Subtract 6. Negative 2z, 4 minus 6 is negative 2, so negative 2z equals negative 2. I divide by negative 2, z equals 1. So I've got x and z, now I go back to the first one and find y. 3 times 2 minus y, I'll make that a negative 1y. Plus 2 times z, so 2 times 1 is 11. Three times 2 is 6, minus 1y. 2 times 1 is 2, equals 11. Negative 1y plus 8 equals 11. Subtract 8. Negative 1y equals 3. And got a negative 1. Y equals negative 3.
just for my sanity. How many matrix C are you going to make us do?
We won't do anything more than, well, what we'll do for solving equations with 3 by 3. Anything bigger than a 3 by 3 would be an extra credit question.
And are we going to be asked to check matrices too?
No. So yeah, this one would be 2, negative 3, 1. If you didn't catch it while I was creating the equation.
Okay, we already have that.
Yeah. There was a day when I could just keep that in my head and do the equations, but I'm not as sharp as I used to be. Well, for homework, in order to keep the homework reasonable, I've got a worksheet I'm going to give it. It only has 6 problems on it. So that's going to be your homework, is the worksheet. What's that?
No grade?
It won't be handed in for a grade. No.